Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to learn about the continuity of a point we are going to discuss. So let us have a discussion the definition of continuity. A function f of x is said to be continuous at a point small a f is defined in a neighborhood of the point A, and limit extends to A, f of x is equal to f of a. So whenever limit extends to a, f of x equal to f of a, then the function is continuous. Next, we will need to learn about left continuous and right continuous. See here, first point, if limit extends to minus a minus, limit extends to a minus means x is less than a. Dear students, you have to remember, f of x is equal to f of a, then f of x is left continuous at x is equal to a. If limit extends to a plus f of x is equal to, here f of a minus f of a, then f of x is right continuous at x is equal to a. So that means to exist the continuous function at x is equal to a, it should be limit extends to a f of x, that is also equal to limit extends to a minus f of x, that is also equal to limit extends to a plus f of x. So we will discuss one example regarding this. The function f of x equal to 3 power x minus 1 whole square divided by sin x into log of 1 plus x when x is not equal to 0 is continuous at x is equal to 0, then find the value of f of 0. Yeah, just this is the example, theoretical example I am giving here. F of x is continuous at x is equal to 0, they are saying. So we know that f of x is continuous at x is equal to 0, then limit x tends to 0, f of x is equal to f of 0. They are asking to calculate f of 0 only, no? So to get the f of x equal to f of 0 value, we need to find the limit x tends to 0, the function f of x. So here, that is f of 0 equal to limit x tends to 0, 3 power x minus 1 whole square in place of f of x, the given, you have to write it, sin x into log of 1 plus x. So we will find out this limit. In the numerator, 3 power x minus 1 whole square is there. In the denominator, sin x and log of 1 plus x. So dividing numerator and denominator by x square, dividing numerator and denominator by x square. Why only with x square? I will explain in the coming steps. So limit x tends to 0, 3 power x minus 1 whole square divided by x square whole divided by sin x divided by x, 1x we are writing here, log of 1 plus x divided by x. So limit apply for the numerator, limit apply for the denominator, both the functions. So limit x tends to 0, 3 power x minus 1 whole square by x square means we can write as like this, 3 power x minus 1 by x whole square whole divided by limit x tends to 0, sin x by x, limit x tends to 0, log of 1 plus x divided by x. So now we have the formulas. We need to learn all the formulae. Without formulas, here I am writing all the formulas, whatever we are going to apply here. Limit x tends to 0, a power x minus 1 by x is equal to log a to the base e. This formula we are going to apply. And one of the formulas is standard one, limit x tends to 0, sin x by x is equal to 1. And third one, limit x tends to 0, log of 1 plus ax divided by x is equal to a. So for the numerator, it will becomes, numerator value will becomes what? Log a value is what here? 3. Log a to the base 3 whole square divided by limit x tends to sin x by x value is 1. Limit x tends to the log of 1 plus x by x. X coefficient is how much here? 1. So that value also 1. So f of 0 equal to log 3 to the base e whole square. So the value of f of 0 is log 3 to the base e whole square. This is the way we will find the continuity of the function. Next, continuity in open interval and continuity in closed interval. Even that discussion also we will do that. So I'll write as a formulas points, we will write it. A function f of x or simply f is said to be continuous in an open interval open interval means like this it will be. This is called open interval of a comma b. So f of x is said to be continuous in open interval of a comma b if it is continuous at each and every point in the interval open interval of a comma b, that is in interval a comma b. See, the figure will come like this, just roughly. This is the real number line, this is minus infinity, this is plus infinity. Here the point a is there, here the point b is there. Open interval of a comma b means we will write like this. So here in every point in the open interval the function is continuous means the function is continuous in open interval of a comma b in everywhere in the interval. In case of open interval, what is that? This is this is the open interval. In case of closed interval, what is the definition? How to define? A function f is said to be continuous in closed interval of a comma b if here points are there. In open interval means in each and every point in the interval the function is continuous. It is continuous in open interval of a comma b. But in the closed interval a function f is said to be continuous in closed interval of a comma b if here point number 1, f is continuous at each point of a comma b, and second point f is right continuous at x is equal to a. Third one is at x is equal to a means we can write like this now. Limit x tends to a plus f of x. F is left continuous at x is equal to a, that is limit x tends to a minus f of x. Sorry, at b it is not a, it is b. That is the only difference in the x tends to b minus f of x. You have to remember in the closed interval f is said to be continuous means first point f is continuous at each and every point in a comma b, each point of open interval of a comma b. And second one is f is right continuous at x is equal to a, that is limit x tends to a plus f of x. F is continuous at x is equal to b, that is limit x tends to b minus f of x. In these cases the function is this is closed interval concept now. So it is closed interval. The function is continuous in closed interval. So when the function is discontinuity, what are the possibilities? Discontinuous. The concept of discontinuity. When we say that the function is discontinuous, so discontinuity we will discuss. In what way we will discuss as the function is discontinuous? If f of x is not continuous, if f of x is not continuous, at x is equal to a, we say that f of x is discontinuous at x is equal to a. If f of x is discontinuous at x is equal to a, in any of the following cases, the following cases. See, we will discuss what are the cases. So let us discuss point by point here. The first point, limit extends to a minus f of x, that means left hand limit, and limit extends to a plus f of x, both are exist, that means left hand limit and right hand limit both will be exist, but are not equal. This is the first case when the function is discontinuity. Come to the second one, limit extends to a minus f of x and limit extends to a plus f of x, both will be exist and are equal but which are not equal to f of a. So both left hand limit, right hand limit will be exist and which is not equal to f of a. This is the second case. That means what is the possibility? The second case, how to write it? Limit extends to a minus f of x is equal to limit extends to a plus f of x, but should not be equal to f of a. This is the possibility. And another possibility, this is the first possibility, limit extends to a minus f of x, this value is not equal to f of a, but it should be equal to limit extends to a plus f of x. In case third possibility is also there. What is the third possibility? Limit extends to a minus f of x, that means left hand limit is equal to f of a, but it should not be equal to right hand limit. Limit extends to a plus f of x. These are the possibilities when both limits exist, left and right limits will be exist, but not equal to f of a, means this is the case also will arise. And in the third case, the Roman letter 3, third case, f of a is not defined. F of a, we cannot define that. F of a is not defined. And in the last case, the fourth one, at least one of the limits, at least one of the limits does not exist, does not exist. These are the cases the function is not continuous or discontinuous. Let us take the example based on the objective question. See here, the function f of x is equal to cos 3x minus cos 4x divided by x square for x is not equal to 0, 7 by 2 for x is equal to 0. At x is equal to 0 is, options are available. First option continuous, second option discontinuous, third option left continuous, fourth option right continuous. See, we will check that f of x is at x is equal to 0, then we have f of x is at x is equal to 0, then we have limit x tends to 0 f of x is equal to f of 0. So f of 0 value is given in the question. At x is equal to 0, f of x value is 7 by 2. Observe carefully here. At x is equal to 0, f of x value is 7 by 2. So that means given f of 0 equal to 7 by 2, you put that equation number 1. See, if you prove that limit x tends to 0, f of x value also 7 by 2, then the function is continuous, if not discontinuous. So now considering limit x tends to 0, f of x is equal to limit x tends to 0 cos 3x minus cos 4x divided by x square. We have here one shortcut formula. In the limits we already discussed, but still we have to. Limit x tends to 0 cos ax minus cos bx divided by x square is equal to b square minus a square by 2. So based on this formula, b square means 4 square minus 3 square divided by 2. So 16 minus 9 divided by 2, which is equal to 7 by 2. So therefore, limit x tends to 0 f of x is equal to 7 by 2, which is also equal to f of 0 from 1 on 2 f of x is continuous at x is equal to 0. So conclusion is f of x is continuous at x is equal to 0. So first option is the right option. We will discuss one more question and then we will Stop the session. The function f is defined by f of x equal to x into sine of 1 by x for x is not equal to 0, 0 for x is equal to 0. At x is equal to 0 is first option continuous, second option right continuous, third option left continuous, fourth option cannot be determined, can't be determined. See how we have to do this procedure. According to the question, at x is equal to 0, f of x value is 0. So given f of 0 is equal to 0, put that equation number 1. F of 0, how it will comes? By taking the limit x tends to 0, f of x. So in place of f of x, what value you have to take that? That function is x into 1 by x. Sorry, x into sine of 1 by x. So x is equal to 0, directly if you substitute 0 into anything is 0. So directly this value goes to be 0. So limit x tends to 0, f of x equal to z2 from 1 and 2. Limit x tends to 0, f of x is equal to f of 0. That is also equal to 0. Therefore, f of x is continuous. At x is equal to 0. So, the option is continuous. I hope everyone understand that. Thank you dear students for watching our channel Maths with Panindra. Please do share and subscribe to our channel. Thank you all.